Hi, welcome everyone to the session 4. And today, the basic objective of the session is to go through the first stage of exploratory data analysis, EDA. And for that, I have taken a case study. So we'll look at the case study and then look at uh, already curated data and understand what steps typically we do when we do the exploratory data analysis, the basics of it. Some of the advanced topics again we'll cover in the coming sessions. Uh, so for this, I also have uploaded a worksheet on the GitHub location. So if you go to the GitHub location, ML course V1, let me save that on chat window. There is a folder created called session 4 now, and in that there is a data set called used cars, maruti.csv, and there is a worksheet here. You can download it. Okay, and we will be using live coding today uh, to do this exercise for this session. I'll give you a minute here. So can you download that and open this notebook on your local Jupyter notebooks? And then you can say done or chat yes on the chat window. I'll wait for a minute. So I'll take you through this worksheet today. And first I will set the context of the session, and then we'll understand the basics, the context of the case study as well. And then we'll get started with the worksheet. Please say done or yes on the chat window once you are able to download and open it on the Jupyter notebook. Am I clearly audible? Can someone confirm? Okay, thank you. So the case study is about resale value of used cars, right? Imagine like you are trying to build a portal for you listing of used cars, right? So there'll be of course there'll be sellers who want to sell their they currently they own the car, and then set of buyers who will be the another set of actors who will no, buy those used cars. So when you build a portal, of course, you're going to provide features for the sellers to kind of upload the details of their cars and quote a price, right? Quote a price for their car. And then for the buyers, you will provide a feature to kind of search for car details. Based on the features, they can search for the cars. And then they can also quote their price, right? So this will go on back and forth, and there'll be a transaction if both buyers and sellers agree on a particular price point. But what we have observed that over a period of time, there is a possibility that the sellers sometimes overquote a price, right? And which takes a longer time to sell their cars, right? To find the right buyers to sell their cars, and which probably lead to customer dissatisfaction or a longer cycle. So your portal of course site earn some revenue only when the transaction happens, or if they underquote the price also sometimes. It might so happen, of course, the seller will probably get a buyer quickly, but when they realize that it's sold a lesser price, it may also lead to customer dissatisfaction. Same thing for the buyers, right? So over a period of time, you want to introduce a new feature or a value added feature, right, to the customers, saying that you upload the details of your car and we are going to estimate the price of a car, right, and provide you what is the best resale price, estimated resale price at which the car can be sold, right? Then of course the sellers can add a little premium to that and quote their price, okay? And of course your assumption is that will lead to faster transactions and you know a reduction in customer dissatisfaction. But how to estimate the price, estimate the resale price of a car? Then of course you interact with the salespeople and you look at the data and say what factors are typically influence the price of a car, right? So there could be several factors. Of course, typically this is the step in any machine learning problem, right? Once you identify the problem, which in this case is how to estimate the resale price of a car, right? The first thing is you identify factors that influence the outcome. Here in this case, the resale price. So the first step would be to identify factors, right? So identifying factors is requires a lot of domain knowledge, right? Of course, some domain could be very intuitive, but certain domains need real good knowledge about the domain. For example, if you are defining a problem in a healthcare domain, right? Of course, you need somebody who understands the domain, or probably you will actually consult with the healthcare experts, right? Let's say you want to build a model to predict uh, the probability, the likelihood of somebody getting a disease, right? Then you will actually go and talk to the healthcare experts and say what factors that we can, once measure through the diagnosis process, and then which can actually lead to the prediction of the likelihood of somebody getting a disease or not. Similarly, if you go to financial domain or retail domain or insurance domain, right, the people who actually understand will actually have some intuition about these factors, right? So I have taken this use case as a first case study because this kind of use case typically we'll all have some amount of intuition, so you can actually understand these factors. Okay, later we'll take some little more complex case studies. So here, if you look at some of the domain experts in this area, could be the people who actually sell those cars, right? On the resale shops, right? Or you can also look at some of the websites where you can partner with those websites and collect certain data and look at what sellers are or buyers are asking questions, right, to negotiate the price of a car. Of course, from intuition, you can understand some of the factors could be, what is the age of the car, right? That could be one of the most important factor. What is the model of the car? Okay, so in this case, of course, we will take only all the cars of Maruti to estimate the price. What is the fuel type? Sometimes you will ask, okay, this is a petrol car or the diesel car, or uh, which owner is this? The first owner or second owner, right? The owner type, right? Can you guys mute yourself? I think some background noise is there. Or you can also ask questions like, what's the kilometer driven? How many kilometers the car is driven, and so on and so for the different factors, right? And then of course you can go and collect data, but in this case data collection could also be very complex process. We'll come to some of the little bit advanced topics, okay, data collection a little later, but in this specific scenario the data collection means Of course, because you're already built a portal, and let's say for sometimes you're already dealing with those transactions, so you would have already generated certain data in your system, right? You can make use of that. If you have captured those factors during the process of sale historically, right? Or you can also partner with the resale chains, right? You can collect data from them, or you can also scrape, but scrape is of course you have to understand the legality of scraping. It's not possible to scrape data all the time, right? Maybe you can partner with those other portals which are collecting data, right? Again, when you collect data, you also have to understand other important aspects, like you should not be very biased. For example, let's say you're opening or building a portal and facilitating buyers and sellers across different regions in India, so you cannot partner for a retail chain, right, or a resale um, uh, chain, and then you can only partner with for a particular location like a Bangalore or Mumbai or Delhi, right? You have to collect sample data from different locations and all that. Otherwise, your data will only contain, because there could be factors like location might be influencing the price of the car. The same car, what is the resale value would be different resale value in a different location itself, right? So data collection process is a little complex. Um, first step is always a problem definition. So if you go and look at in any ML lifecycle, typically the first step is the use case identification and problem formulation, right? We will dive much deeper, slowly and slowly, how to actually define a problem, more concrete definition of a problem when you go through multiple different case studies, right? So this is basically where you identify, what is that outcome that you are trying to predict. So in this case, the resale value of a car, right, of a car. And of course, you also have to define certain things like what is the accuracy expectation. But then we will discuss this a little later, because you need to understand what is the accuracy means. Okay, and when you come to next case studies, we'll properly define what is accuracy expectations are. And then of course you can also identify factors, right, which would be typically influence the outcome and all that. And there are quite a few other specific requirements that has to be identified or captured or defined during the problem formulation itself. And once you do that, then you go to the stage of data collection and preparation. So this itself can take a very long time, and this could involve both effort to collect data. It could also be cost, right, time factors. It'll take a longer time to, depending on the context of the problem, it can actually take quite a few months to even collect the data, right? Even there can be also the cost associated with it, because all the factors that you've identified to predict the price or outcome in your problem definition, right? Not necessarily it will come from the internal data, it can come from the external sources also, and that might involve paying for it, so that there might be a cost involved along with that as well. So not necessarily you can build models only with the data that you are collecting or your organization is collecting. Sometimes you have to also collect data and get data from external sources, and there are a lot of these data companies who can provide data to that can be utilized or leveraged for your model building. Of course, because this is a training session, this is a classroom context, so this is we are already have a curated data set to work with, right? But we'll go through some of the important aspects of data collection, how much data, right, what kind of data, how to deal with the bias in collection, all that over a period of time, because everything cannot be explained through only one case study. When you look at multiple case study, you look at those problems. And then typically a data scientist job starts first whatever you have collected with the exploratory data analysis. This is where whatever factors that you have identified uh, from intuition of the domain experts or understanding of the domain experts, right? You need to correlate here. Do they really affect the outcome or not? Okay. Or what is the data quality? Okay. Are there any missing values? Are there any outliers that you have to deal with? Do you need a derive certain features, or do you need to transform certain features, right? Look at the distribution of the data. All these steps has to be done through exploratory analysis. So this is a very important step, right, called EDA, which stands for exploratory data analysis, okay, which will lead to certain decisions of, right, uh, whether you need to collect more data, whether you need to collect more factors at the initial stage, whether you need to transform certain features, derive certain features, right? All these decisions would come from the stage of EDA. Then of course, then we'll move to model building and validation and so on and so forth. So we'll look at all the steps as we go forward, right? So what we'll do is now, for this we have already collected a data, a curated data, um, which is in the GitHub, and it looks like this. So for this particular problem, we have only taken the data of only Maruti cars. So estimate the resale value of the Maruti cars. Okay, and then the certain factors like, you know, the whether it's a petrol or diesel car, the fuel type, right? What is the transmission, whether it's an automatic or manual car? What's the owner type, right? The first owner, a second owner, and so on and so forth. How many seats it has, okay, that also tells you the model of the car, kind of, and then the age of the car, how old the car is, right? From the data purchase, what is the model, what mileage it gives, what's the power in terms of bhp, right? And how many kilometer driven in terms of 1,000 kilometers. So that's basically 87,000 kilometer, right? 87,000 kilometer in terms of 1,000 kilometers. And then of course, at which location the car was sold, because there might be an influence of location itself on certain estimation, price estimation, resale value. So we'll of course look at that, whether the location itself has an influence on the resale value or not. And then of course, at which price the car was actually sold. So what we'll do is we will now go through this data and do the first round of exploratory data analysis. And how do we actually look at each variable independently? How do you look at variables together and understand their impact, and so on and so forth. So for this, what we'll do is let's open the EDA used car resale price worksheet. Okay, so what we'll do now is I will actually do the live coding. We'll basically go through this. You can notice or observe this, and then what you can do is later also you can play this video again and do the coding yourself, right? Of course, at the end of the session, I will also give you the completed worksheet so that you can go through it. Okay, and in the worksheet, I have also given like participant exercises in between, right, based on what we have done so far. And there are about 10 different exercises are there. Okay, so the exercises are something that I'm going to skip, not do in the class, in the session. So I'm expecting that once the session is over, you can go do that and basically submit that as an assignment. Okay, so let's start with this. So I have also given an explanation of the variables here. The price is going to be the resale value price of the car, the target, and then the other details like a model, location, age, what we've seen so far, right? Now, the first thing is, of course, we're going to load the data set. So I'm going to load the data set first. So import pandas as a PD. Typically, we import these two libraries to start with. So the pandas and numpy, as we know that. And typically, it's always a good idea, as you've already seen some of the previous session, some of the steps would be still be repeated here for the completion perspective. but we'll quickly go through that. So it's always typically good idea when you load a library to look at the version of the libraries that you're dealing with. So pandas is about 1.5.3, and the numpy is the version number 1.24.2. Typically you have to look at the major version. The minor version there will be little bit of discrepancies with that. And normally when we first we can load the data, right? We can load the data and show few records. So you can say cars df equal to pd dot read csv, right? So pandas has a different read commands to read different kinds of files, and we can use csv here because this is a csv file, and then we can give the file name, right? The file name is used car maruti csv, so it's going to read the data, and then we can look at some of the records. This is the first 5 records. So here is the car which was sold in Chennai. It was actually an Ertiga, Maruti Ertiga, driven for about 87,000 kilometers. It gives around 20 mileage, right? It's a manual car and got sold at 6 lakh rupees. As you know, you can also look at some of the metadata, like cars df dot shape gives you the dimension of the data set. So about 1070 rows and 11 columns are there. Okay, out of that 10 columns are the factors which are influencing the outcome, and one of them is the outcome itself, which is the price here. And then for cars df you can also do info, which gives you little more information about the data frame, about the column names, and also gives you the null counts, which is basically if there are missing values are there, right? As the first case study I have taken a clean data, but later when we come we'll take it little more complex, missing values and all that, right? And the data type it identifies, automatically it infers from the data. Don't rely on this much. You need to understand your variables and then map it to whether it has been identified correctly or not. So as we know that the variables are of 2 types, right? Numerical and categorical. So categorical variables are typically identified as objects, and numerical variables should be identified either as an integer or float values. Then we can do some indexing and slicing of records. For example, let's say I want to look at the first 5 records, so I can say 0:5, and I can look at some of the first few records, and then I can also do, let's say, last 5 records, right? So -5, that will also show me the last 5 records. So I can the range of records, the start index and end index, this is not including, that's why I say 0 to 1, 0 to 4 only. You can also look at specific columns if you want. Let's say cars df, and I want to look at only the model name, right? For the first 5 cars. So you can actually give the column name indexes here and the row name indexes, the range of indexes here. And I can look at one column or multiple columns also. So to look at multiple columns, what I can do is I need to create a list, right? I have to give the list of column names. So cars df, so I'll say model. So if you see, there are 2 different brackets. The first bracket is for index, then I'm giving a list here, then the list are again rounded by brackets, and let's say price, right? And first few rows. So I look at the model and price for the first 5 records. So I can do indexing and slicing, and then I can also sample records. So cars df dot sample. I can randomly sample 5 records and look at the 5 records as well. Um, I can also provide a seed value. We've already looked at the seed value, but I'll come back and tell you about the seed value little later. Okay, so this is about, of course, when you quickly load the data, look at few records, randomly look at certain records, look at certain columns, look at the metadata, right? Try to understand the data, right? And then you can start your analysis. The first analysis that typically you do is called univariate analysis, looking at one variable at a time, right? For example, you can ask, of course, in this case, we know that there are 2 different transmissions are there. For example, what different locations are there, right? So we'll first look at, okay, what are different transmission types and how many cars are available for each transmission type in terms of percentage. So what is the distribution of manual cars and automatic cars? Then we can do what? And transmission being a categorical feature, we can do cars df dot transmission, and we've also seen this earlier. We can use value counts, right? So what value count will do, for each of the unique value in the categorical feature, it will count the distribution, right? It count the number of the frequency of it. So in the data set, there are about 976 manual and 94 automatic cars are there. And sometimes we don't look at typically for analysis perspective, we don't look at the absolute number of counts, but we look at the percentage, right, the frequency of it. So we can look at the same thing, value counts, and then we can provide something called normalize equal to what? True. So about 91% are manual and 8 to 9% are automatic, right, in this sample. Now, one question you might ask is, what is the point of knowing, right? Or what is that information you can actually derive out of it? One is, when you look at the distribution of manual and automatic, right? So in your data set, about 8%, isn't it? 91 or 9% distribution, manual and automatic. But then you'll go and also do a little external analysis from third-party providers or vendors, saying that, okay, typically what is the distribution of manual and automatic cars in the resale car resale world, right? So let's say in the real world, the distribution typically is about 60% are manual and 40% are what? Automatic cars. Okay, this of course is obtaining from third-party providers or some other sources, right? Then you know that what data you have sampled here is completely biased towards manual. It does not reflect the real world distribution. Okay, so it might be possible that while you're collecting data, right, there is some bias, and because of that you have mostly collected manual car data and very less of automatic cars. Okay, this is of course not very easy step, but you have to go and verify, or you, on the domain experts, you can always ask, is this distribution of data for the manual automatic is correct or not, right? So EDA is a process where you to keep involving the domain experts or business guys continuously in the process of EDA, because what you find in the data, okay, you have to if you find some questions, right, you'll go and always ask the business and make sure that it actually reflects the true distribution of the real world. But let's say in the real world it is about 85 to 15%, so it probably is okay, right? Not much of a discrepancy. But then you can also do if you remember in the last session we discussed about chi-square test, right? The chi-square test, what we did is, when you toss a coin, let's say 100 times, typically if it's an unbiased coin, right, it's a fair coin, typically you're expecting 50 times head and 50 times tail, isn't it? Typical the distribution should be like this. But in real world you don't get 50-50, you might get, let's say, 60-40, right? So even this is your observed frequency, this is your observed frequency, and this is your expected frequency, isn't it? And when this is your expected frequency, there is a likelihood that you might observe this also. Okay. So you can actually go and do a little bit of chi-square test, saying that what I have observed here, okay, does it, is any different than the expected frequency? Let's say 85 and 15, right? If the probability value is less than 0.05, then you know that no, what I'm observing is very different than what is expected, right? So then there might be a bias in collection, right? These are all things you have to do continuously in the EDA process. Again, some of the advanced steps we will do in the later sessions. I'm just giving you some intuition behind what can be done, right? Of course, if the expected frequency is 60-40 and you observe this, the likelihood of observing this is very, very low. You directly know that from experience, okay? But you can also do this test to figure that out, right? So you have to look at some of the key variables and see that whether my sampling process is correct or not. Okay. If any questions, please paste the question on the chat window. I'll answer it. The whole process of EDA is asking questions about the data and then deriving certain information or insight from the data, from the sample, and then again asking question, what I'm observing is same as what should have been, right? What is expected or not. Of course, it's not possible to verify for every possible variable, but some of the important variables you should always ask this question and do the analysis. So here I have given an participant exercise to do the same thing for owner type, right? How many are first owner, how many are second owner, and so on and so forth. So you can do it as a part of the exercise when the session gets over. No, it is not imbalanced data set. Imbalanced data set is, there's a question called, is it imbalanced data set? I'll come to imbalanced data set, which is primarily the distribution of the outcome variable, not the features. So this is basically a factor, right? This is not really an imbalanced data set. I'll come back to that when we take a specific problem where there's imbalanced. We can also filter records, right? Let's say for specific analysis, we want to just take a subset of the records by a condition and filter, and then look at that. For example, let's say how many cars were sold that were 15 years old or more. Then you can apply a filtering record there. You can say, okay, old, very old cars, or old cars df equal to, you can say cars df, cars df dot age, right, which are 15 years or more, right? So it's more than 14. So you can filter all the cars based on the condition. We've already seen this before. Now you can apply one condition or multiple conditions with and or operator, right? You can do that. And then how many cars? We can look at the shape. So there are about 34 cars which are more than 14-year old. Okay. This is also important from the perspective like if you look at the cars which are 15-year old has a different regulatory requirements nowadays in India, right? It has to be renewed and it has to be verified and all that. So whether you want to deal with those kind of problems here, or you want to only take the cars which are less than 15-year old, that's again a business decision, because cars which are 15-year older, you might need some additional information to estimate the price of it, right? So because there's a regulatory requirement, right, more than 15-year old, it has to be scrapped or renewed, or a lot of other complications there, and that might influence significantly the price of a car, right? So when you build a model, you have to think whether you have to include those cars and include those information to estimate, or if those information are not there, it's better to exclude those cars from the data sets, right? So not necessarily everything is purely based on data. Sometimes you have to bring in all those information like a compliance requirements, regulatory requirements, additional information to estimate something, and you see whether in the current context you can actually use them to estimate or not use them to estimate. Mhm. So for this time, what we'll do is, for this particular exercise, we will take out all the cars which are 15 years and older. Again, that's not a much of a sample. Only 13 to 34 cars are there, so we'll keep them aside. So what we'll do is, now we'll say cars DF. Okay. We'll apply the same thing again, but this time we'll say keep all the cars only which are 15 less than 15-year old in the data set. Okay, we'll eliminate the remaining one for the time being. Okay. But again, like I told, this has to be done from by understanding the problem domain very deeply. Now let's look at within the cars which are less than 15-year old, what are the most and least expensive cars? The cars which were sold with very high price and cars which were sold with very least price. Just want to sort them and look at them, right? So you can say cars DF, okay, to sort by anything, right? And you can use sort values. You don't have to filter now. Now it's basically sort values. Is this not the car? Yeah, cars DF. Now let me cars. That's what spelling is wrong. Sort values by price, right? And then say ascending equal to false. And let's say you want to look at only the top most expensive cars, right? So we'll sort by price. Then you can specify what, ascending or descending. So in this case, descending, because from the highest to the lowest, and top 5 cars, right? So you can look at this particular car called Vitara, which was sold at 10.19 lakhs. It was only, of course, 2-year-old car and driven for only 57,000 kilometers. Mm-hmm. And similarly, you can also look at the least expensive cars. So I have given that as an exercise here. So in the exercise, I want to look at the 10 least expensive cars that were sold only in Bangalore. And for those cars, I just want to look at the names and the sold price. So you can actually apply filter and apply sort value and indexing and arrive at this. See if you can do that in a single statement. Now let's look at the distribution of resale price. Again, distribution is something that we have explored extensively in the first 3 sessions. So we'll go quickly here. For example, all these cars were sold in different price ranges, right? So I want to know, okay, how many cars were sold in the range of 1 to 2, 2 to 3, 3 to 4, and so on and so forth. And as we know, we can do that in using histogram, which is, we already done it before. But for the resale price, we'll look at the histogram now. Okay. So we can say PLT. I've already imported matplotlib as PLT C1, and some styles I've set for the better visualization of the plots. So plt.hist gives you what? The histogram, right? And then you can look at cast df dot price, and as we want the specific price ranges, right, 1 to 2 lakh, 2 to 3 lakhs, we can create our own bins, which we have done earlier also. So we'll say, you know, 0 to the maximum price is how much? 10.19. So it'll go from 0 to 11 at the range of 1. So I have to execute this. So I can look at the distribution, the histogram of the sale price, and to kind of little better plot this, I can resize the plot by providing what, the figure size which is, let's say, 12 6. The width is 12 and the height is 6. So you can see the resizing the plot. And then I can add certain things like the label and all that, right? So X label is nothing but price. My Y label, so this should be the price, and Y label is, you can say, the frequency or the count. And I can also provide a title in the histogram of price, resale price, right? Typically, it's a good idea to always provide this X levels and Y levels, so that it's much better readable. So you can look at that. The cars which are sold mostly were between 2 to 3, 3 to 4, and 4 to 5 lakhs, and it's mostly look like a normally distributed, which you already gone through earlier, isn't it? You can also provide the ticks. By default gives you 0 to 4 and all that. You can also provide or X ticks, plt dot X ticks, which could be very same as this, the bins that are given here. So in this case, you can see, so every bin is basically now labeled here. So 0 to 1, 1 to 2, 2 through 3, and all that, so on and so forth. So if you look at any particular numerical feature, you can always do a histogram and understand the distribution of it. So here, of course, this is a histogram of the price. As an exercise, you can do the same thing for kilometer driven, which is a bin size of 10,000 kilometers, right? So every 10,000 kilometers, 0 to 10,000, how many cars were sold? 10,000 to 20,000 kilometer driven, how many cars sold, and so on and so forth. And when you do this analysis, the first thing that you also want to understand is, are there any outliers in the data? And to do the outlier, there are two different approaches that we already discussed. One is standard deviation approach and box plot approach. So you can apply that here in this EDA, right? So like, for example, as a standard deviation approach, if you remember, we can do from SciPy import starts, and we can look at the interval. Remember, in the normal distribution, you can look at the -3 standard deviation to the +3 standard deviation. Right? So that's where we already discussed that in previous sessions. So directly look at is starts, and we are assuming that this is a normal distribution, and then you look at the interval, right? And the interval is what? If you look at the -3 standard deviation to +3 standard deviation, the interval is about 99.7%, 99.7%, right? So it can be written like 0.997, and then the cars df, the first parameter would be what? The mean value of it, and the second parameter would be the standard deviation. So it's saying that for 99.7%, it should be from -1.77. Of course, we can assume that to be 0, okay, and the highest should be about 11.06 lakhs, right? And because we know that the maximum price at which one of the car was sold, the max price was 10.19. So we know that there is no outlier in the data, because the distribution can lie between 0 to 11 lakhs. So in this case, there are no outliers there. But we can also, of course, because there are no outliers here, we can be very assured that this is the right approach to find the outliers, because the mean and standard deviation won't be influenced by the outliers here, but there are no outliers there. But if there are outliers, typically we can also look at the box plot approach, but you can also I will also do that here for the completion perspective, right? So you can do sn dot box plot, right? You can look at the sn dot box plot, and we can provide cost df dot price. We can give change the size of the plot as well, but in this case probably I'll give a little lesser, let's say. Yeah, that's fine. And we see the median value is about 4 point something, and the mean again is here about 0 point something, and max is 10 point something, right? But we can calculate that. If you remember, we had done that. We can say cost df dot price dot median. So that's a median price. So 4.29 lakhs here, the median price. And then we have to figure out what is the the IQR, the interquartile range between the 25% quartile and 75%, right? And then we can do this value, whatever the V1 minus 1.5 of IQR, okay, which should be the minimum value, and 75%, whatever the value is, plus 1.5 IQR, which will be the V2 value. So let's do that here. Let's find out the IQR value first, which again we can do from starts dot IQR. So cars df dot price is saying the IQR is about 3.149 lakhs. And to find out the V1 and V2, right, we can look at the quantiles, or you can also do something called describe, which also gives the values. The 25% quantile is basically 2 point percentile is basically 2.95, and 75 percentile is 6.10. So this is your V1, this is V2. The difference is, of course, will be around 3.14. So how do I now estimate the mean and max price? So max price would be nothing but, let's say I capture this into price stats, let's say. Let me capture that into variable so that I can use it. So price stats, and this comes as a dictionary actually. So it would be 25%. Let me check if that is correct. Yeah, 2.95, that looks correct. Minus 1.5 multiplied by what? IQR. So again, let me capture that into a variable called IQR. And yeah, so max price would be, oh, this will be mean price, sorry, isn't it? This will be mean price, because I'm looking at 25% minus of 1.5 IQR, that's a mean price. That will be minus 1.77, and the max price would be max 75% here, and plus of 1.5. So that comes out with 10.825. Okay, it's a little different than this one, which is fine because the data is a little skewed. It's not a perfect normal distribution, but anyway, in spite of that, we don't have any outliers because the maximum value sale price is 10.19 lakhs. Even box plot approach saying that the maximum value can go up to 10.82. Okay, so there are no outliers in this data, which is good. But as an exercise, you can look at the kilometer driven and see if there are any outliers in the data in terms of both standard deviation and box plot approach, right? So you look at the distribution in terms of hist plot, and you can find those also. By the way, for univariate analysis for numerical features, we can do box plot, or we can also do distribution plot. So let's see if we can do a distribution plot also. For distribution plot, we can say, let me take the size of the plot, and I can say plt or sn dot kde plot with, yeah. So kde plot is will take the whole uh, data frame as the data, and then you can specify which particular column we can use for the kde plot. So this shows a distribution of the price data distribution, right? The sample distribution. So it looks fairly normal. Little bit of right skewed. That's there are no outliers in the data. Okay, so we looked at two things now in univariate analysis, right? One is we looked at one categorical feature called in univariate analysis, which is looking at one variable at a time, and we looked at one categorical feature, uh, one categorical feature called transmission, isn't it? And transmission, and one numerical feature called price, right? So for this, we can just look at the value counts, and for this, you can look at histogram or KD plot. So there's a question called what does this negative number means? So what is saying that the distribution, the way the data is distributed, the frequency, the value can lie somewhere from, in this case, if you look at the interval minus 1.77 to 11.06. The minimum value can be minus 1.77, okay, minus 1.77 to 11.06. Okay, so minus 3 standard deviation to plus 3 standard deviation. Okay, this is estimated by statistics, but in typical business sense, right, the negative number doesn't make any sense because you never sell a car for negative price, right? The minimum value would be probably few thousands. So in that case, we can assume it to be zero here, okay, because statistics doesn't know it's a price, it's just a set of numbers. So you always have to interpret what you get from the statistics. You always have to interpret from the perspective of the domain also, right? Your negative value doesn't make sense. Now let's look at one more, the car models and distribution. So this is of course the price distribution across all cars, isn't it? All different models, Ertiga or Swift or SX4, all different. But how does the price distribution looks like for each specific models, right? So for example, Ertiga cars, right? What is the sale price looks like, right? What is the sale price for the gen, right? We can actually also do that comparison. So then we will actually looking at two different variables, right? But first, let's say what are different models are there. To do that, even to go there, first we look at what are different models are there in this data set. So then this will be very similar to what we have done for transmission. So we'll say cars df dot model dot value counts, and we can see these are the specific models are there: Swift, Alto, Wagon are basically Ertiga, Ciaz, and so on and so forth. I think all these models we are pretty aware of it. But one thing you will also observe here are the certain models like Esteem or S Cross or 800 and so on and so forth. There are very few cars are there. Okay, so you don't have probably have enough information here to kind of understand. If there are not enough samples representing that particular model, it may not be possible to learn what the resale price of those cars would be. Okay, we need some basic uh, representation, right? So typically what we call them is rare categories. We normally call them what? Rare categories. So for example 1, 3, 6, anything less than here you can actually consider them to be rare categories. So either you can combine them into one single category called others. Typically, the way you deal with the rare categories is either you can combine them into one category called others, or you can drop them from the data, saying that currently I am not going to support price estimation for this specific models because I don't have enough sample to understand and learn from them, right? But other cars maybe I have more. Um, so either go and look at the distribution, the real world distribution, how many esteem cars are sold. They're very rare. Then of course you will never have that understanding how the price are getting estimated. So you can drop them from the data as well. It's always a good idea to kind of, when you build a model, rather than building a model very generically, to predict, I can, the model can predict anything and everything. You can always constrain, right? You can always put a boundary saying that I will build a model only for this specific set of models, for say this set of attributes or whatever, right? You can always do that. So that will improve the quality of the model as well. So the top 10 selling models are what? Swift, Alto, Wagoner, Ertiga, and so on and so forth, right? So let's capture that information into that a, a variable so that we can do some analysis about the top 10 selling models, because quite a few models are here. So to capture that, what you can do is we can capture this particular results into a data frame, right? Like you can say um, models bf equal to dot reset index. If you do reset index after do value counts, it actually going to return a data frame rather than basically a series. This is called series, a data frame with the two different column names, right? Here the column on which you are doing value counts will be written as an index, and the counts will be written as a model. Okay? So what you can do is you can also rename them appropriately, saying that the first column should be called actually the model, and the second one can be called what? Counts. And then we can look at the head 10, right? So these are the models, top 10 models, and their counts in the sorting order, in descending order, right? So we'll create a variable called top 10 models and store only the names of the cars. Okay. I'll tell you why I'm doing that, because we'll go and do some plotting for this frequency distribution of these models. Sorry, I have to do only the top 10. So 0 to 10, top 10 models, because quite a few models are there. So if you do it for every model, then the plots look quite cumbersome. So I'll only limit it as of now. Typically, you might have to do for everybody, or take the first 10 and then take the second 10 and so on and so forth. But I'll just, for the exercise here, I will only limit this only for the top 10 models, right? We can also look at create a variable which models we can remove from the data. Like we already seen that the models which has a very less frequency, isn't it? Less than 10. So you can say models to remove is either you can hard code, or you can also say uh, models df. So any model that has a count less than 10 will take those names, right? And we'll just store it as of now that these models can be removed from the data, right? So I've done what here? I've filtered out all those records from here, which is a less than 10 counts, and taken on the model name and stored into a variable. So I create two variables now. One is top 10 models, the higher frequency, and the list, uh, the models with the least frequency, which is less than 10. Okay, so I'm going to use them later to do analysis and remove or clean data sets. You can also do an exercise here. You can plot the number of cars sold for each year of car edition, right? I will show that also. So what you can do is also here, um, we can plot this, right, as a count plot, because we've already seen this before. Let's do sn dot bar plot data equal to models.df. In the bar plot, we can say x equal to the model and y equal to the counts. Again, I'm going to change the size of the plot for better visualization. Yeah, maybe a little more. So here we also depicting the same information in terms of plot here. So Swift has the highest count, Alto is the next, Wagoner, and so on and so forth, right? You can see these are the cars with very least frequencies. Okay, so far we have seen three variables overall: the transmission, the price, and the model, right? So now what we'll do is we'll look at some bivariate analysis. So analyzing two variables, right? For example, if I want to understand what's the average selling price of top 10 models, we've already identified this top 10 models. Typically, what's the average price? Of course, it doesn't make much sense to look at only the average price, because the dispersion could be very high, the standard variance. And of course, the cars with different ages, different will be, of course, different prices and all that. But just to get a sense of the dispersion, we can look at the average price first, and then we look at the distribution also, right? So to calculate the average, what you can do is you can say average price for models equal to cars df, right, group by model, isn't it? So each model one group will create, and within that group we will look at only the price, right? So each model look at the price and calculate the mean value of it. Okay. So here you can see the average sale price of 800 is about 1 lakh rupees. Swift is about 4.74, S Cross is 7.95, and so on and so forth. But of course, when I say 4.74, of course, there'll be cars which are sold much higher than this and much lower than this. So can I look at the distribution of each model? Like we have looked at the distribution of price across all models, can I look at for each model independently? Okay. So then this is a very popular plot here. So you can look at that. You can say sn dot box plot. Okay. This is quite often we do this actually. Cars df. Here x equal to your model, right? X equal to model, and your y will be equal to price, I guess. Yeah. Again, I will going to resize these plots so that you can better visualize it. Yeah. And this is a very popular plot. If you look at very interesting plot also. So rather than looking at the distribution of overall all models, you can look at the distribution of all the models. And again, the too many models here. So what I'll do is I'm going to limit this to only the top 10 models for the timing, right? So we have already captured the top 10 models. So what I'll do is I'll put a filter here saying that this only do this for the cars where the model name is in this particular list. So there's a nice API function called is_in. So this will what will do is, as long as the name is in this top 10 models, only those will be filtered. And uh, okay, I have to put one more. Sorry, this has to be square brackets. It's not function. So you can see that I'm only plotting the top 10 models here. And you can also provide, I think you can provide an order. I'm not sure. Let me check. Yes, this makes sense. So from the Swift, Alto, Wagon, then the same order of frequency. And you can look at each model independently. For example, if you look at the middle line here, right? If you look at the middle line here, uh, in this case, this is the median value of Swift cars, right? 4 point something. Alto, and you see the typical median price for Vitara is quite high, because that probably is a high valued car. Vitara is quite high. And you can look at the Desire has a very high dispersion standard deviation, okay, ranging anywhere between from 2 lakhs to what, 8 point something, probably about 9 lakhs here. Whereas the average resale price of Vitara itself is about 9 lakhs. And of course, there are certain outliers also there. So this is the highest median value, and the lowest one would be Alto here, Alto and Wagoner. And Celerio and Swift seem to have the same median value, very similar median value, but dispersion here is quite high. And you can also see there are quite a few outliers in specific models. For example, there are certain Wagonars which are sold more than 6 lakhs, which seems to be very, very, unexpected resale value for them. Whereas the Balinos, some people have sold the Balinos for less than 2 lakhs, almost close to probably 1 lakh, and so on and so forth. Of course, this could be influenced by the age factor and other factors as well, because we have not brought in the age factor here as of now. Of course, the expectation is typically the cars that you see which are sold more than the median typically should have a very less age, and less than median typically would be very high age cars, right? That means older cars. But then of course we can look at that little more detail with more analysis, but this also gives you some insight into, category wise distribution of outcome variable, which is a price, and then we can get some insight into it. Okay, very, very popular graph. This is primarily used for comparing two variables, which we call it a bivariate analysis. So in this case, the two variables are what? One is your model and one is your price. Okay, so one variable x1 is model and the other variable x2 is price. So you do a box plot by category. So these plots are done when you're doing with the two variables v1 v2, where one of them is categorical variable. It has to be, one of them has to be categorical and the other one is numerical. Okay, because when you try to understand the relationship between two variables, right, v1 and v2, the three possible scenarios are there. One, both are categorical. Two, one of them is categorical and one of them is numerical, okay, either Cn or Nc, and the third one is both are numerical, right? In the second case, typically use a box plot. Okay, you can also do KD plot by category, but I will do it later for another example. I have actually the rules for plotting. I'll explain that once we're done this exercise. So you should know those when to do what kind of plot in what kind of scenario when you're dealing with the variables. so that you get to know, right, or get to choose the right plot for your analysis. Okay, the same thing here, you can do it for find out variations of sale prices for only Swift model for different ages. So what I had done it for different models across various ages, right? Now we'll dive now a little deeper into Swift itself, this itself, all right? And then what you can do is you can look at different ages. So 1 year old, 2 year old, 3 year old, 4 year, 5 old, and the price of the car only for the Swift cars, right? We'll filter out and do it, but I'll give that as an exercise. You can do it, and then you can look at what influence uh, on the median sale price the age of the car has. So as the car becomes older and older and older, how the median price, okay, increases or decreases. Typically, it should decrease. That's an intuition says, but you can observe that as well. Now let's look at the demand of models across various locations. Okay, this is an interesting plot because here we are dealing with two variables. One variable is called a model, and one variable is called what? Location. And you can see the v1 and v2, both variables are of type what? Categorical. The model is categorical and the location is also categorical. Then how do you observe this? The demand. For example, if you look at all the cars, for Swift cars, right? What's the demand across Bangalore or Hyderabad or Chennai and all that? Or you can also ask a question saying that of all the Maruti cars that are getting resold in Bangalore location, which models has highest demand, right? That you can look at through this analysis. So let's do that. So when you two categorical variables are there, of course there are multiple different plots you can do, but the very important plot that we can do is called cross tabulation, right? So we can do models by locations, right? Locations equal to pd dot cross tab. Okay, this is a cross tabulation function. If any of you have used this in Excel, it's easier to understand, but it's not a very complex one. So let me first do that. So you can say cast df dot, right? Cast df dot let's say model versus cars df dot locations. And location, and you can print this value. So you can see but this actually gives the actual frequency. For example, let me do the other way around, which makes a lot of sense. Location. So the way in the order that you give determines whether it becomes rows and columns. So look at it. So in Ahmedabad, of all the cars sold, okay, you can see the frequency of each of the cars, right? And you can see Swifts are more frequent here, the Altos are frequent here, and so on and so forth, right? But you can normalize the data again, like we can rather than looking at the actual value of it, you can normalize the percentage. So to normalize it, what you can do is you can again use a function called normalize. But normalize in a two-dimensional table is not simple, whether you want to normalize by row wise or column wise. Row wise means what? That means you can do sum of all the cars, how many total cars are sold in Ahmedabad, and then we can divide the count by each frequency. So it tells you what percentage of Alto, right? The percentage of Alto cars sold uh, compared to the all the cars sold in Ahmedabad, right? And so on and so forth. So you can do something called normalize equal to index, which basically does it row wise. Right? We can see that now. So you can actually, rather than getting actual frequency, you're getting the actual percentage. Again, looking at this percentage numbers, it's not very readable, right? So what you do is, it's a beautiful plot called heat map, right? We can put this plot into, in this data, into heat map, which is much better to kind of read it. So what I'll do is, I'll take this figure size, so to change the shape size of the plot, and then say sn dot heat map, right? And give this number, uh, right, to the heat map. So it's going to put a heat map here, but then I can't read the numbers. So what I'll do is, I will also do something called annotation equal to true. Okay, we'll also do plot these values here, which is a little better. Let me increase the size of this little. And because the numbers have last decimal values, I will also limit it to formatting, saying that 0.2 f formatting, and it will choose a better color code. Okay, so normally I like this yellow, green, and blue. Blue is, I think, blue. Yeah, this looks a little better. Hopefully you can read this. Maybe I'll just give me a second. I will probably increase the. Yeah, I think this is good. Okay, so if you see here, very interesting. And okay, I'm only going to again limit this by only the top 10 models, because there are too many numbers to read. So what I'll do is, I'm going to limit this only for top 10 models, so that way it will look better. So let me do a top 10 cars df equal to cars df. Remember, we did this model is in top 10 models, right? So I'm going to limit this only for the top 10 cars, so I'm not going to use it for all the cars. Yeah, so a little better to, yeah, it makes sense. So if you look at the plot here, heat map, it's a very interesting plot, and this is on the right is your scale of the color in terms of percentage. The light means low percentage, and the dark means higher percentage. And each row is a location: Ahmedabad, Bangalore, Chennai, and so on and so forth. And each column is what? A model. Right. So immediately you can see from the heat map that the pretty good demand for Swift cars, right, across all locations, especially in the Maruti uh, manufacturer. There are quite a few demand across different locations. Some are high and some are low. So the very high demand cars for resale, right? Then there are certain other cars. For example, Wagoner has a pretty good demand in terms of Kolkata, Mumbai, and Pune, but not other locations like Bangalore and all that. Okay, and Alto has a pretty good demand in Chennai and Hyderabad. This is actually interesting. The pretty demand actually there, and uh, the cars like Desire seems to have a very low demand across all locations. Not sure why, but at least from this data, it looks like, again, all these intuitions or inferences that you get from the data, you go and verify from your business or domain experts, right? uh, does that really true, or basically there's a problem with the sampling, we have not collected enough data and all that. But these are, I think, we have quite a few data, right? If you look at Desire, we have the frequency is quite good, not bad at all. Just of course 24 cars only cross compared to Swift and all that, but this is again normalized rate. Okay, so this is a pretty good plot, especially when you want to understand the distribution or the relations between two variables which are categorical in nature. So model and locations, you can choose to do the normalization by index or by column, which again depends on the question that you're asking. So in this case, of course, we want to understand the demand of different models by location. So we had done the indexing based on location. So that's basically the row wise normalization. So if you add up all these numbers, if you add up, this will be equal to 1.0, right? Every row will be 1.0. That means all the total cars, 38 or 40% of the cars sold in Ahmedabad are Swift. Okay, pretty high these numbers are. So I have given an exercise here to find out same thing, the demand for different fuel types of cars for different models. For example, for a Swift, what's the demand for diesel and petrol? For Ertiga, what's the demand for diesel and petrol, right? So you can actually look at the fuel type, or you can look at the transmission type, right? We can actually compare to different variables like that. Okay. So in bivariate, what I have done so far is we have looked at two variables. One is the combination of numerical and categorical. We have done a box plot. We looked at categorical and categorical, which is a heat map. And we can also look at um, numerical and numerical now. Okay, we can look at also numerical and numerical. But before that, I'll show you one more plot also you can do, which is categorical. For example, if you want to also see, I will take, let's say, what's a demand of automatic and transmission cars across different locations. So in this case, one variable is transmission and the other variable is location. So we can also do something like this. Let's see if we can do it. So cars sn dot, you can do count plot data equal to cars df and x equal to location, right? So this will give you what different cars. Let me again change the size of the plot, right? Yeah, so the number of cars in this sample, you can see the most of the cars from Hyderabad, then Kolkata, Pune, Bangalore, and so on and so forth. But whatever the cars sold in different locations, what's the split between automatic and transmission, right? Or you can also look at something like fuel type or something, um, right? Let's say look at fuel type. So the second variable, so each of this particular frequency, like Chennai, right? In Chennai, out of the 80 cars sold, what is the distribution of, let's say, you know, automatic and what's the distribution of manual? So here, what's the automatic, what's the distribution of manual, right? We can further split it, which is called hue. Okay, stacked plot kind of. It's a hue, and we can say transmission, right? Yeah, this looks. Or you can look at something more interesting would be fuel type, I guess. Hopefully. Uh, yeah, yeah, that's interesting. So of the cars that sold in each location, you can the distribution of petrol and diesel. The diesel is blue and petrol is orange. So you can say Hyderabad there is a pretty good demand for both. Like Delhi also it's good demand. But Kochi, there seems to be a good demand for petrol car. And Jaipur, there's a good demand for diesel car higher. But of course, this could be just because of the observation. But here you can see there's a pretty good discrepancy. Mumbai, there's a good demand for petrol car, not diesel. Coimbatore also same thing. Right? You can see the different frequency distribution of fuel type across different locations. Okay? So you can see the fuel type also plays a relationship, an important role in the demand of different resale cars. Okay, so you can also do compare two different variables like this. Um, so you can try this plot also here for the participant exercise. You can do a heat map as well as you can do a bar plot like this. These are called grouped bar plots. They are called, I think, grouped bar plots, right? So the plots are grouped by a third variable like location here. Okay, so we look at now one of the last plots is called a scatter plot. Again, we have seen before, but then how mileage is affecting the resale price. And here mileage is a numerical feature, and price is also a numerical feature. So we'll use a scatter plot. Remember, we had done this for comparing uh, the sectoral indexes with the market index, right? And see the correlation between them, right? And we have seen how banking sectoral indexes are highly correlated with the market index, but the healthcare sectoral indexes are not highly correlated with the market index, right? So here we'll see, does mileage affect the resale price? The intuition typically says yes, the higher mileage will have higher resale value, but what the data says, so you can go and do what, sn dot scatter plot data equal to cost df. X would be mileage. Typically we look at the factor in as a x and the outcome as y, right? In this case the price, and sorry, mileage is m capital, p is p capital. Yeah. And we can also do a they can see a positive correlation here. As the mileage increases, the price also increases, right? You can also do something called reg plot, which actually shows a regression line, a direction of the relationship, which shows you it's a positive correlation. So you can do both reg plot as well as scatter plot. Of course, there's a positive correlation, as our intuition says. The same thing you can apply to kilometer driven. That means the higher the kilometer driven, what's a resale price of the car. And in this case, the intuition says the more you're driven, the lesser is the sale price. Again, you can see our intuition is correct, and it says, let me change the plot sizes. The default plot sizes are not good. Okay. It again says that, yes, there's a negative correlation between kilometer driven and the price, right? As the price reduces as you're driven more and more kilometers. Of course, you can see the frequency of cars which are driven more than 1 lakh kilometer in the resale market is very low. Okay, most of the cars are sold lesser than that, probably around this, and there's a negative correlation. But the correlation value, remember, the correlation value will lie between -1 to +1, which shows the strength of the correlation. So here's an exercise to look at few other combination of factors. But if you want to find the correlation between multiple variables, what you can do is you can say cost df, and with price you want to see, let's say, age. You can do all simultaneously. Power, then you can say mileage, and kilometer driven. Let's keep it this much only. So these are the 1, 2, 3, 4, 5 numerical features. We'll go and say let's look at the correlation between price, right? Then you can say CORR, which shows the correlation matrix, right? And you can see price has a very strong negative correlation with the age. It makes sense. As the car gets older, you get a lesser resale value. Mileage have, and power, especially power, has a good correlation strength actually between price and power. Kilometer driven, very weak correlation, but there is a negative correlation. Okay? So on and so forth. Again, this particular data can also be captured into a matrix, and anything that you see um, right as a matrix can also be depicted in a heat map like we did earlier. So you can say heat map correlation matrix, right, and say annotation equal to true, and formatting equal to 0.2 f, only two decimal values, and you can give a color map. Here I'll tell you why the color map will be a little different. We'll use something called diverging palette. I will tell you why we are doing this. And we can also provide something called V mean and V max. Let me do this and I'll tell you why I'm doing this. Okay, because correlation value will vary from -1 to +1. I want to depict the positive correlations with different color and negative correlations with a different color. So I am using a diverging palette, so two different colors. So if you look at the color palette here, all the positive correlations are shown in red, all the negatives are shown in what? Blue. And I know that the maximum correlation can be -1, actually +1, and the minimum will be -1. So I just limit that there because in the data there won't be probably in -1 +1. And the darker is the red, the stronger positive correlation. Darker is the blue, the negative correlation. Again, you can see from the plot here that let me change a little bit of size again. Okay. So you can, from the plot, you can see that the price is, especially if you have a very large number of numerical features, it won't be very convenient to read through this matrix, right? Once you calculate this matrix, it's not very readable here. So put that into heat map and quickly you can see, okay, very strong correlation here, average correlation, strength here, positive correlations, and these are the negative correlations, right? You can quickly check, especially if you're looking at a price, you know that this is strongly correlated, right? Because the darker the color, but because it's blue, it's a negative correlation, and because it's red here, it's a positive correlation. This is a weaker correlation. You can quickly look at it, and you can also look at other correlations between other variables. Like this is a negative correlation between age and mileage. So as the car gets older, it starts giving lesser and lesser mileage. Make sense? And age and kilometer driven is a positive correlation. Makes sense again. The older the car, the more you have driven the car, which makes sense again. Okay, so quite a few intuitions can be verified here as well. Okay. Now what I'll do is I will going to save the data. So I'm going to remove certain models from the data. So I'll say final cars df equal to cars df, right? And then I'll put a cars df dot model is in, if you remember, we created a list called the models to remove. Models to remove. Okay, so let's remove those from the data. So this data now can be taken for further analysis. So you're going to store the data. So cars which are uh, in this particular list, okay, we can eliminate them. So you can put a negative here. You only choose the cars which are not in this, right? Uh, so if you look at finally cars, final car DF shape is 1010, and original cars was 1036. So 26 cars are removed, which is fine. And then what you can do is you can go and save the data into a CSV file. So final cast DF, you can do 2 CSV like you did a read CSV. You can also do a 2 CSV. So final cast Maruti.csv, and there is a option called index. So besides the data, it will also create something called 0, 1, 2, 3, 4. If you want a column like that, you can say true, but I don't want that, so I'll just say false, right? So I'm going to do a only store the data columns. So if you go to your folder, uh, let's see if I can go to folder. Yeah, so there is a file created called final cars Maruti, and for some reason so now this is the data that is I have stored here, which is after filtering out the cars which are more than 15-year-old, those are removed, and the cars which are, so I have removed the cars which are more than 15-year-old, and I have removed the models which are very less frequent, right? So I've stored the data here. We haven't done any transformation of the data, which will of course do it later, but this is anyway the first step of analysis. So you can also see how to actually store data in Excel or a JSON format. Also you can try out. Okay, so what I'll do is I'll conclude quickly with the rules for plotting. So when you do analysis, you have to do two kind of analysis. One is called univariate and one is called bivariate. For univariate analysis, you have two choices, right? The variable is either categorical or numerical. So if it is a numerical and continuous especially, you can use histogram, box plot, and distribution plot. This is nothing but your KDE plot. If it's a categorical, you can do count plot or bar plot. Okay. You can also use this for your discrete variables. Though discrete variables are numerical features, you can use the same rule for plotting the discrete variables also, because discrete variables will have a very specific integer values, and the frequency, the number of possible values won't be very large. For two variables or bivariate analysis, there are three options again: continuous categorical, continuous continuous, categorical categorical. So for continuous categorical, you can do box plot or a overlapped distribution plot. This is something that we have not tried. We'll do it in the coming sessions. Continuous and continuous, you can do scatter plot or heat map. Remember, we did a correlation heat map. For categorical, you can do a bar plot and heat map. We did both now. Right? This is a grouped bar plot or heat map, like a cross tabulation. So this is of course basic rules for plotting, if you remember. A little more advanced are there. We'll come back and look at that later. But this is fairly going to cover quite a few scenarios. We can also look at three variables, but looking at three variables, there are few plots are there. But anything more than that is hard to visualize, right? So anything more than that, 2 or 3, we normally build a mathematical model to understand the relationship, which of course we'll do in the coming sessions. But this is the basic steps for EDA. Okay. So what I'll do is I'm going to upload this also to the GitHub. Okay. And what you can do is, as part of the assignment, you can complete those exercises that I've given here, and you can send me the link on the Discord group, right, to verify that. So you must know this fundamentals and foundations so they can build up on that in the coming sessions. I'm going to stop the session here.